In this video, we will push the boundaries of what is possible with Llama 3.2, a tiny open source model that you can run on your own machine by building this advanced multi-stage RAG agent. This flow might look intimidating, but let's simplify it before we jump into the detail. With a traditional RAG agent, you would have a user sending a question to an AI agent. So the agent will use an LLM to try and answer the user's question and respond with some answer. Now, of course, we can also add RAG to this flow by adding some sort of additional knowledge to the flow, like a vector store, a database, a PDF file, or it could just be pretty much anything else. So the agent will try to do a semantic search to retrieve the most relevant information from the data source and inject that into the LLM's prompt. Now, this agent will work fine for very simple use cases, but it can also introduce some problems. For example, when the agent reaches out to the vector store, it's very possible that the documents returned from the database are not of a very high quality or not related to the user's question. The accuracy of the documents returned can depend on quite a few things, like the vector store being used or the embedding model that was used. So bad data can lead to hallucinations, and that is where the agent will kind of make up its own answers, which are not factually rooted in what is being returned from the knowledge base. And secondly, the agent will try its best to use the data returned from the knowledge store to come up with some sort of answer. And that response might actually not answer the user's original question. So what we can do instead is build agentic RAG systems. These workflows execute several steps that will ensure that the quality of the responses are greatly improved. This implements several concepts that are being used today to build these advanced RAG agents. First of which is routing. With routing, we can direct the user's question down different paths to retrieve the data that's the most relevant to the user's question. For example, for certain questions, we might want to go to our vector store or our knowledge base, or for certain questions, we might want to do a web search instead. For example, to retrieve live information. The second technique that we will implement is called fallback. This means that after we've retrieved the data from the vector store, we will use another LLM to first check if the documents returned are actually relevant to the user's question. And if the documents are not relevant, we can try to do a web search instead. And lastly, we have a technique called self-correction. This means that after we've retrieved the most relevant information, we will use an LLM to try and answer the user's question from the context, but before showing the answer to the user, we will use another LLM to check the answer for any hallucinations and that the answer is actually relevant to the user's question. And if it's not, we can attempt to rephrase the question or simply respond with something like, "I couldn't find the answer." Now let's visualize these three different techniques, and afterwards we'll build this flow in Flowise. As with the normal RAG agent, our user will send the question to our RAG pipeline. Now, this first agent will actually not try to answer the user's question outright, but instead, it will actually look at the user's question and try to determine what the correct data source would be. We will call this a router agent. It could decide to go to the knowledge base, like a vector store, or it might determine that a web search would be the best approach. So we will provide some instructions in this agent system prompt to help it make this decision. So for certain information, go to the knowledge base, and for other info, just do a web search. And of course, this knowledge base could be a vector store, a database, a file, or whatever else. Or if we do a web search, we can use something like Tavily or SERP API or any of those services, effectively allowing our agent to do a Google search. Irrespective of which route we decided to take, we should have some information available. So you would think that it would make sense to generate an answer at this point, but we still have the risk that the information coming back from the vector store is still not relevant to the user's question. So what we can do instead is break this connection and then add in another agent into the mix. And this agent is responsible for checking the relevance of the documentation returned from the knowledge base and then provide it with some sort of grade. If these documents are semantically similar to the user's question, then we can go ahead and generate an answer. Or if this agent determines that these documents are not related to the user's question, then it can fall back to this web search instead. So that means we will discard the documents that we retrieved from the knowledge base and attempt to find the answer from the web instead, and then try to generate an answer. So that covers routing and fallback. Now let's have a look at the final technique, and that's called self-correction. So what we can do is add another agent to this flow that's responsible for checking the answer generated from this LLM to ensure that there are no hallucinations and that the answer actually is relevant to the user's question. If the answer is relevant, we will pass that response back to the user. Or if the answer is not relevant to the user's question, or it contains hallucinations, then our agent can simply respond with something like, "I don't know." And of course, you can take all the techniques that you learned in this video to take this a step further, where this agent will first try to go to a different data source, or even try to rephrase the question for the web search and try again a certain number of times, before eventually responding with "I don't know." So in today's video, you will learn a lot. And this is a slightly more complex topic, but it's definitely worth learning if you want to take your agent game to the next level. So let's finally build this out in Flowise. I do want to mention that this example is inspired by this article written by the LangChain team, where they do something extremely similar, but coding it out using LangGraph in Python. So instead of writing this in Python, we will try to build this using a no-code platform called Flowise. And by the way, Flowise is also using LangGraph behind the scenes to make this all work. I also want to mention that you can download this flow for absolutely free, and you will find a link to it in the description of this video. This video was a lot of work to create, so if you do enjoy it or find any value in it, then please hit the like button and subscribe to my channel. So to get started, go to Agent Flows and click on Add New. Let's save this flow by giving it a name, something like Multi-Stage RAG Agent. Let's save this. I will assume that you know the basics of using agent flows, so if you are new to agent flows and sequential agents, then check out my crash course over here, and then come back to this video. Let's start by adding a start node to the canvas. So under sequential agents, let's go to Start, and let's add this node to the canvas. Let's start by adding a chat model. Let's go to Add Nodes, Chat Models, and let's add the Chat Ollama node, because we do want to demonstrate the ability of using small models like Llama 3.2. But of course, you're more than welcome to use OpenAI, Anthropic, or any other model. If you're unfamiliar with Ollama, it's an awesome tool that allows you to run open source models on your own machine. Check out my dedicated video on setting up Ollama, especially this one that shows you how to build a RAG chatbot using Ollama and the Llama 3.2 model. So for the model name, let's enter Llama 3.2, and we'll be using the 3 billion parameter model. Let's set the temperature to a lower value like 0.2, and let's assign the chat node to the start node. We're not going to add agent memory in this tutorial, but you're free to do it in your version as well. I'll simply add state. So under add nodes, let's add the state node, and let's assign it to the start node as well. At the moment, the state node does not contain any values, but we will use this to control the state and the behavior of this application during the course of this video. So just to test that the LLM is actually up and running, I'll simply add an LLM node like so. I'll simply call it LLM, and finally, let's connect an end node just to complete this process. Let's save this flow, and in the chat, let's simply enter "Hey," and I do get a response back, meaning that the connection to Ollama and the Llama 3.2 model is working. I just added this node for testing, so I'm going to delete it, and instead, let's have a look at what we want to build. First, we want to receive the user's question and then use an LLM to route the question down different paths. Either we want to retrieve data from the knowledge base or simply perform a web search. So let's start by building this router. Let's go to Add Nodes, then under Sequential Agents, we want to do some routing. So either we can use the condition node or the condition agent node. The difference is that with the condition node, we can simply look at a specific value and then hard code the path that we need to follow. Because we're not looking at a very simple value, we have to intelligently look at the question that the user is sending and use an LLM to decide where to route to. So let's add the condition agent node. Let's attach the start node to this condition agent node, and let's call this the router agent. And under additional parameters, let's set a system prompt as well as a human prompt. In the interest of time, I'm actually going to paste in the prompts, but as a reminder, you can download the entire flow for free from the description of this video. You can then easily import that flow into your Flowise instance and copy across my prompts. But in a nutshell, we're saying that if the question is related to things like agents, prompt engineering, and adversarial attacks, then reach out to the vector store. Or if the question is not related to those topics, then perform a web search. We're also telling this agent to return a JSON structure with a single key called data source, which contains the values web search or vector store. We will use these values to figure out where to route the question to. And this is simply telling the agent not to try and answer the question itself, but to simply return that single value called data source. For the human prompt, we can simply create a variable called question, and we can then assign a value to that variable by clicking on Format Prompt Values. Then let's click on this Edit button, let's click on this field, and let's select the question from the chat box. Now, of course, we want this node to produce a JSON structure with this data source key, so I'll actually copy that value. Then under JSON structured output, we can tell this node to return a JSON structure as the response, and we can define the exact fields that we want to get back. So I am expecting one field called data source, which is of type enum. So enum allows us to provide specific enum values that we expect, like vector store and web search. And for the description, I'll simply enter data source. Let's close this pop-up. And now all we have to do is set these routing conditions. So we could set them within this table, which is easy enough to do. But what I don't like about this approach is that we will always have this end output over here. I simply want the routes to either be vector store or web search. So under condition, I'm actually going to switch over to the condition code menu, but don't worry, we won't be writing any complex code in this video. Let's click on see example, and what we can do is replace this content part with the value that we are outputting in this JSON structure. So just to have a look at that value again, we are creating a property called data source. So what we can do in the code is to replace content with data source. So result will now give us whatever value is captured in data source, and we can now see if result includes any of those values. So if result includes vector store, then we want to go down the vector store route. I like to keep these two values the same. Then let's also copy this and paste it below. And for this one, we want to see if result includes web search. And if it does, we want to go down the web search path. And I do not want this end route. Let's save this. And now on this node, we can see that we only have the vector store and web search paths. To test this out, let's add 2 LLM nodes to this canvas. So I'll add one over here. Let's call this one the vector store LLM. And let's also attach this end node for now. And let's also attach this vector store route to this LLM node. Let's copy this node. Let's move it down here. Let's also copy the end node. Let's attach it to this LLM node. Let's attach this web search path to the LLM node as well. And let's rename this to web search LLM. Now at the moment, these LLM nodes won't do much because we simply want to see if this is actually working. So let's give an instruction like respond with vector store route. And let's do the same thing for the web search node. So we'll just say respond with web search route. Okay, let's save this. And in the chat, let's see if this is working. What is a React agent? So because this question is referring to agents, we should expect this flow to go to the vector search LLM, which it does. And we can see that our router agent determined that the vector store should be called. Let's try something else, like what is the current weather in New York? Let's send this, and this time we've been sent down the web search path. Great, so that means our router is working. So let's go ahead and set up this vector store logic, and afterwards we'll work on the web search logic. So the first thing we need to do is to set up our knowledge base. Let's go back to the dashboard. Let's go to document stores. So in the interest of time, I've already set up a document store for us. And in this document store, I'm scraping information from these web pages. And I then set up the config for this document store to use the Ollama embedding model. And I'm using the Flowise vector store that simply creates the vector store database on my local machine. If you're new to document stores, then definitely check out my dedicated video on setting up document stores the right way. So back in our agent flow, let's improve this LLM node. I'm actually going to disconnect this end node, and in this vector store LLM node, let's do the following. For the system prompt, we can simply use the provided tool to answer the user's question. And in the human prompt, let's enter a variable called question, and in format prompt values, let's assign a value to question, and that will be the question coming in from the chat window. Then let's add another node to this canvas, and that will be the tool node. And then let's assign this LLM node to the tool node. I'll simply call this tool node vector store tool. Now let's go ahead and assign our vector store retriever tool. So under tools, let's add the retriever tool. Let's assign this to the tool node. Then for the retriever name, I'll call this a knowledge base retriever. And for the description, we can enter the vector store contains documents related to agents, prompt engineering, and adversarial attacks. Finally, let's attach our document store. So under nodes, go all the way down to vector stores and add the document store node and attach it to the retriever tool. From the drop-down, select your document store, and I'm also going to enable return source documents so that the user can see where this information was retrieved from. At this point, let's attach this tool node to this end node. Let's save this flow and let's test this. What is a React agent? So in these messages, we can see that the vector store tool was indeed called. This node called our knowledge base retriever tool, passing in the keyword React agent, and this is the response that came back from our document store. We can also click on this button, and this will take us directly to that web page that we scraped. There is one change that I do want to make to this tool node. The reason for this will make sense as we progress with this video, but I do think it's a good idea to set this up now. As you saw in the chat, this tool node retrieves documents from our document store, and then those documents could be passed along to the next node. But what I want to do instead is actually write the documents to a state value, and we can then use the state value to continue with our process. That will also allow other nodes in this flow to override the state value. Let's go back to our state node. Let's add a new property called documents. And for the operation, let's select replace. And initially, this will have no value. So what we can do now in the tool node is once we get a response back, we can update the state value by adding a new item. Then under keys, let's select documents. And for the value, let's select the flow output tool output. This property contains the output from calling our vector store tool. And we can now close this. We are now done setting up the knowledge base retrieval. So let's move on to the second route, which is the web search. So let's go to this web search LLM. Let's click on additional parameters. For the system prompt, let's enter use the provided tool to answer the user's question. And for the human prompt, let's enter a variable for the question. Then let's click on format prompt values. Under question, let's select the question from the chat box. Now let's also assign a tool node. So under sequential agents, let's add the tool node like so. Let's attach the LLM node to the tool node, and let's call this tool node web search tool. Now thankfully setting up web search is really easy. Let's go to add nodes, then under tools, let's add SERP API, and let's attach it to the tool node. Now if this is your first time using SERP API, then simply go to serpapi.com and register or sign into your account. And you can then simply copy your private key from the dashboard. And then within this drop-down, click on Create New. You can give this credential any name and then paste in your API key. Now on the tool node, click on Additional Parameters. Then under Update State, click on Add Item. Then let's select Documents. And as the value, let's select the tool output. This is exactly the same thing we did with the vector store tool node, and this will simply store the results from the web search in the document state. Now to test this out, let's connect the tool node to this end node. Let's save this flow. And in the chat, let's ask something like, what is the current weather in New York? And if I expand this, we can see that the router decided to go down the web search path, which is correct. We can see that the web search tool called the SERP API tool, which in turn searched online for the latest weather and returned the following results. Great. So at this point, we are receiving documents back from our vector store, but it's very possible that these documents are not really relevant to the user's question. And that takes us to the second technique that we can implement in our RAG solutions, and that is this fallback technique. With fallback, we can add another LLM to the chain, and this agent will be responsible for checking the relevance of the retrieved documents in relation to the user's question. If these documents are not relevant, then we'll fall back to a web search. Otherwise, we'll continue to generate an answer. So what does this look like in Flowise? First, let's scoot over this end node, and let's go to add nodes, and let's add another conditional agent. But instead of connecting the tool node directly to the condition agent node, we're actually going to add another LLM node in between these two nodes. So I'll simply add the LLM node, and then I'll connect the tool node to this LLM node, and I'll then add this LLM node to the condition agent node. So why am I doing this? This actually resolves an issue within Flowise, whereby if you connect a tool node to any node before or after it, that node will have access to this tool node. So that means that if we didn't have this LLM node in between, then this conditional agent might actually attempt to call the tools provided by this tool node, which is not what we want. So in order to make the tools inaccessible to this node, we will simply add this dummy LLM node, which actually won't do anything. It's simply there to create a buffer between the tools and our condition agent node. You can of course try to omit this node, but if you do experience funny issues whereby this node is trying to call this tool node, then simply add this padding in between. I hope that makes sense. For this dummy node, I'll simply give it a name like vector store dummy. And for the additional parameters, I'll simply add a prompt, do not respond, do not call tools. And that's really it. Now for the condition agent, let's give it a name like grader LLM. After all, this agent is going to do grading on the documents and then return either yes or no. So under additional parameters, let's add a system prompt and a human prompt. For the system prompt, let's enter, you are a grader assessing relevance of the retrieved documents to a user's question. If the document contains keywords or semantic meaning related to the question, then grade it as relevant. And do not try to answer the question yourself, simply grade the relevance of the document to the question. Then carefully and objectively assess whether the document contains at least some information that is relevant to the question. Then, very important, return a JSON with two keys. A score, which is either yes or no, to indicate whether the document contains some information related to the question. And the second key is reasoning, where you need to explain the reasoning behind your decision. Here is the retrieved document. We will then inject the documents from our state object into this variable called context. Then for the human prompt, let's simply add the user's question. Let's save this. Then under format prompt values, for the context, we will be using the value that we stored in state. So let's select flow.state, this one with replace with key, then click on edit, and let's replace this placeholder with documents. Let's submit this, and as a reminder, we are referring to this documents property that we are storing in the state object. Then let's change the question to the question from the chat window. Now we also want to return two properties from this node. First is the score, which is of type enum, and for the values, we are expecting yes or no. And for the description, we can simply enter content relevance score. Let's add another item called reasoning, which is of type string, and for the description, we'll enter reason for your decision. And this is actually a very handy tip, as we won't see this value when executing this flow, but if you are analyzing this flow with something like Langsmith, then you will be able to troubleshoot your flow using these values. Let's open up condition, let's go to code, let's click on see example, and the value that we want to check is score. Then in the if condition, let's change this value to yes, and let's change the return to yes as well. Then let's copy this if statement, let's paste it just below, let's change this now to no, and let's return no as well. Let's also remove this end route. Let's save this, and now we get these yes or no conditions. So if the documents are not relevant to the user's question, then we can attach this no output to the web search node over here. Or if the documents are relevant, then we can attempt to generate an answer. Let's actually do that now as well. So let's add another LLM node, like so. And I think to keep things organized, let's actually start adding sticky nodes. So let's go to add nodes. Let's search for sticky, and I'll add it just above this node over here. And let's enter generate an answer. So if the documents are relevant, then we'll try to generate an answer. And let's do the same thing for the web search nodes. So instead of just calling this end node, we want to take the results from our web search and also attempt to generate an answer. So we would be tempted to attach the tool node to this LLM node, but as I mentioned earlier, this could cause this LLM node to try and call this tool node as well. So the workaround is just to add another dummy LLM node. So I'll simply copy this one. Let's add it next to the tool node as a buffer. I'll attach the tool node to this LLM node. Let's rename this to web search dummy, and we'll then connect this LLM node to the generate answer node. And of course, we also need to provide a name to our generate answer LLM node, and I'll just call it generate answer. Let's actually add another sticky just above this grader node with a note of check if the documents are relevant, and if not, route to web search. Now let's wrap up this generate answer node. So let's start by attaching the end node. Let's click on additional parameters, and in the system prompt, let's add answer the user's question using the below context. Keep the answer to about 3 sentences max. And we will attach the documents from the state object in a minute, but let's first save this, and in the human prompt, let's simply enter the user's question with the question variable. Then let's scroll down to format prompt values. For the context, let's select this flow state. Let's change this placeholder to refer to the documents instead. And for the question, let's select the question from the chat window. So this node will now take the context that we retrieved either from web search or from the vector store, and then try to answer the user's question from that context. Now what I also want to do is take the generated answer and store that in a state variable as well. So let's go back to our state node. Let's add another item called generation. You could also call it answer or whatever you want. I'll just call it generation. And for the operation, let's call it replace with the default value. Then let's go back to our answer node under additional parameters. Let's scroll down to update state. Let's add an item. Let's select generation. And for the value, we'll simply select the LLM node output. Great. Let's save this, and we should be able to test this flow now. Let's open up the chat window. Let's clear the chat. Now let's first try the vector search path by entering what is a React agent. We can see that the router used the vector store path, which is correct. Our vector store tool retrieved the following information from the knowledge base. Then our grader decided to generate an answer because it found the retrieved context to be relevant to the user's question, and therefore we get a generated answer. Now let's try a scenario where the flow will attempt to go to the vector store and then find that the documents are actually not related to the user's question. Let's ask, what is FlowiseAI and how does it implement RAG? So this RAG text will trick the application to go to the vector store. It should then see that the documents are not relevant and then do a web search instead. So let's have a look at this. As expected, the router decided to use the vector store, and our vector store tool retrieved the following from the knowledge base. Our grader then decided to use the web search instead. So clearly it determined that the documents are not relevant, so now we are performing a web search, and now we are getting the correct answer back. Excellent. So what we'll do as a final step is what is called self-correction. So this agent will be responsible for checking if there are any hallucinations or factual errors in the answer that we got back from this agent. If the answer is correct, then we will return that answer to the user. If we find that the answer is not correct, then we can simply respond with something like, I don't know. Try rephrasing your question. Of course, you can take this as far as you want. Maybe you want to fall back to a third data source, or attempt to call the web search in a loop to try and find a different answer. That's really up to you. Let's go back to Flowise. Let's move this end node, and let's perform this hallucination check. Under Add Nodes, let's add another condition agent node. Let's call this hallucination check. Let's attach the LLM node to this agent, and just for completeness sake, let's also add a sticky note with the text like check for hallucinations. Under additional parameters, let's change the system prompt and the human prompt. Now feel free to pause this video or simply copy this prompt from my agent flow, but this is simply telling the agent to check that the answer that we received is correct, and it needs to return a score, which can be either yes or no. Let's save the system prompt, and then for the human prompt, let's add facts. So these would be the documents that we received from either the web search or the vector store search, along with the answer that we received from the generation node. And of course, we are expecting to receive two keys: a grade, which can be either true or false, and reasoning that contains the explanation for the score. Let's save this. Then under the JSON structured output, let's add the grade, which is of type enum. Then for the values, it can be either true or false. And for the description, we'll enter student grade. Let's add another item. This one is called reasoning, which is of type string, with a description of the teacher's reasoning behind the grade. Let's close this pop-up. Then let's click on condition. Let's go to condition code. Let's click on see example. I'm going to remove this line to return end. Then we want to check the value of grade. So if this includes true, then we will return true. Let's actually copy the statement. Then let's change this to false, and let's return false. Let's save this. Now we have true or false paths. So let's start with the true path. So this means that the answer was correct. For this, let's add an LLM node. I'm actually also going to copy a sticky across. Let's call this final responses. Let's call this LLM node summary LLM. Let's connect the true path to our summary LLM. And let's also attach our end node. Under additional parameters, let's set a system prompt of you are a helpful AI assistant. Use the following generation and format into a friendly and concise response to the user. Do not include things like, here is a concise response. And for the human prompt, we'll simply pass in the generated answer. Then let's go to format prompt values. For generation, let's click on edit. Within this field, let's select this state value. Let's change this to flow.state.generation, like so. And that should allow this node to generate an answer for us. And I think I might have forgotten to set these values in the hallucination node. So let's go to additional parameters. Let's click on format prompt values. For the context, we will select the documents from state. So let's click on state. Let's edit this. And this will refer to flow.state.documents. Let's do the same thing for generation. We will select our state, and let's rename this to flow.state.generation, like so. Right, so we can now close this pop-up, and this means that this node will now be able to check for hallucinations and then direct the flow down this true path, which will summarize and provide an answer to the user. If this node finds that there are hallucinations, then we can go down this false path. For this, I'll simply copy this LLM node. I'll also copy the end node. Let's rename this to something like no response. Let's connect the end node as well, and let's connect this false route to this node. Let's change the system prompt to something like, "You are a helpful AI assistant," and for the human prompt, we can just enter, simply say, "I'm sorry, but I couldn't find the answer to your question." You could try rephrasing the question and try again. Now let's save this flow and let's test this. Let's try a super weird question, like, based on your knowledge base on RAG, what is the current weather in Cape Town? So what happened here was we decided to do a web search, which brought back the current weather in Cape Town. So we then generated an answer from that. Then the hallucination check correctly identified that the response does not actually answer the user's question. And therefore, we are getting the message saying, "I'm sorry, but I couldn't find the answer to your question." So I do hope that you found some value in this video, not just around building agents with Flowise, but also how to include more advanced techniques within your RAG applications. If you found this video useful, then please hit the like button and subscribe to my channel. Also check out these other Flowise videos over here. I'll see you in the next one. Bye bye.